Okay, this is the 50-50 about Pythagoras. It's questions 11 to 20. It says, yes or no, the three side lengths listed in each case form a right-angled triangle. So according to the theorem of Pythagoras, for any right-angled triangle, a squared plus b squared equals c squared, where c is the hypotenuse of the triangle. So what they've done here is they just haven't bothered to draw you the triangle, and they've said here are three sides of a triangle, 9, 12, and 15. So if you immediately look at these numbers, the longest one is always the hypotenuse. So if I draw any random triangle, goodness me, that does not look very right angled. So say I draw any right angled triangle like this, and I call the sides, this one 9 because it's shortest, this one 12, and this one 15. And I say, okay, for this triangle, does A, so I'll say 9 is A, 12 is B, and 15 is C because it's the longest side. Is it true for this triangle that A squared plus B squared equals C squared? And then I'll substitute 9 squared plus 12 squared equals 15 squared. So then you get your calculator or your brain and you go 9 squared is 81, 12 squared is 144, and 15 squared is 225. You should just check that on your calculator. Let me check on mine. Okay, 15 squared is 225. Now, is 18 plus 144 225? Yes, it is. So 225 is equal to 225. What the calculation for the left-hand side over here is equal to the calculation for the right-hand side. And if the left-hand side equals the right-hand side, then this is a true mathematical statement. So number 11, the answer is going to be yes, the triangle is right-angled. So then if we looked at number 12, okay, so this is number 11. If we look at number 12, it says do exactly the same thing. You've got three sides. This 15 must be the hypotenuse because it's the longest. So you draw your right angle triangle and you say your sides are 5, 10, and 15. And you say for a right angle triangle, you state Pythagoras' theorem, a squared plus b squared equals c squared. And then you say 5 squared plus 10 squared equals 15 squared. Okay, so 5 squared is 25 plus 10 squared is 100, but now from the other question we know 15 squared is 225. So 25 plus 100 is 125. So now I've got a mathematical statement that says 125 equals 225. So the left-hand side does not equal the right-hand side. Okay, so then number 12, the answer is going to be no, it is not a right-angled triangle. So this is the one way of doing it, where you substitute everything in, or what you can do, okay, if we just rub out this triangle, so I've got some space to write here, and let's do this in another color here, let's go like this. Or you can say, for instance, for number 12, always state a squared plus b squared equals c squared. So then you say 5 squared, because remember that's the shortest side, plus 10 squared, that's the next longest side, equals c squared. So 5 squared is 25, 10 squared is 100, and that's going to be equal to c squared. So c squared is equal to 120. C is equal to the square root of 125. So what's 125 square rooted? It's going to give you some answer that's not a whole number. It's 11,18. Okay, if you put it into your calculator and you don't put it in surd form. So then I've got worked out this value by calculation for C, and then you say 11,18 is not equal to 15. So number 12, the answer is no, or just the n, like it says to you, write y or n. So for every one of these questions, you go and you find which is the hypotenuse. It's always the longest side. And then you make the other sides A, B, and C. And then you try Pythagoras' theorem, and if a squared plus b squared equals c squared, then yes, the triangle is right angled, and if you were to draw it to scale, you would find it would work. But for instance, if you drew this triangle number 12 with a side of 5 and a side of 10 at right angles, there's no ways you could put the other side as 15 unless you made the angle, the one angle over here, obtuse. So you would end up, goodness me, my drawing, you would end up with a triangle like this, 5, 10, 15, but with a right angle like this, okay, it's 5, 10, and by calculation, that pink calculation over there, this is going to be 11,18, or in third form, 5√5. Okay, so your job is to draw these as imaginary triangles. You don't have to draw the triangle, you can just substitute into the formula, and from there you literally just say, does my left hand side equal my right hand side, or does a squared plus b squared equal the number for c squared? And if it does, then you've proved Pythagoras' theorem and it's a right angle triangle. If it doesn't work, it's not a right angle triangle, and you just answer no.